Here's one more example of solving a system of equations with the matrix equation procedure. So we have Bob, a nutritionist, who has been asked to prepare special diets for a patient, Susan. Bob has decided that Susan's meals should contain at least 400 milligrams of calcium, 20 milligrams of iron, and 50 milligrams of vitamin C. He's also decided that the meals will be prepared from three basic foods A, B, and C. The nutritional contents of these foods are given in the table. Find how many ounces of each type of food should be used in a meal so that the requirements of calcium, iodine, and vitamin C are met. And it specifically says to solve with a matrix equation. So if this were a problem on your exam, you would have to solve with this procedure in order to earn full credit. And if you solve with a different procedure, then you're not going to get the full points because this is what we're specifically testing. So they've already got a nice chart here with the calcium, iron, and vitamin C required for all of the three different food types. And what we can really do is we can just go across the rows here and add those variables in. So everything in row A basically gets an A with it because there has to be 30 grams per food A. Everything in row B will get a B. And the C's down here, and that pretty much makes our equations for us. Whenever you're making your equations, though, be thinking sort of logically. We can't write our equations across because then they would only have one variable in them, and we could just solve them like that. If it was 30A plus, if we went this way, if it was 30A plus 1A plus 2A, well, then we only have A's. Like this would not even be a problem for this class. That would be a very low level type problem to solve. So that can't be how the equations work. The equations have to be set up going down. Also, if you think going down is where we say, okay, well, all the calciums, so all of this first column, all the calciums, there needs to be 400 milligrams at least total. So there's my total of calcium. And then my total for iron is 20, and my total for vitamin C is 50. So now we have equations that actually make sense. They're equations that have three variables in them and that have something set to set them equal to. So it looks like our system of equations then is 30A plus 25B plus 20C equals 400, going down that first column. And then we have 1A plus 1B plus 1C equaling 20, And then we have 2A plus 5B plus 4C equaling 50. So there's our system. So if we want to put this in matrix equation form, AX equals B, where that A is the coefficient matrix. So take all your coefficients, 30, 25, and 20 across, and then 1, 1, 1 across, and then 2, 5, 4 across. That's A. X is the variable matrix, so we have A, B, and C in that order as our variables, equaling the constants of 400, 20, and 50 as another column matrix. So that's our AX equals B formatting. In order to find the answer, because of how we know matrices work, if we know that AX equals B, then we know if we were to multiply on the left-hand side of both by A inverse and A will cancel out as the identity, and we can find X by doing A inverse times B. So the first thing we have to do is figure out, well, what's A inverse? So in an application problem like this, especially with the 3x3, please feel free to use your calculator to find that inverse. If the question is, what is the inverse, then I want to see your procedure for finding an inverse, and it will specify that on the scratch paper sheet. But if the point of the problem, if what we're testing here is, do you understand that you need to find the inverse in order to solve this, now you're welcome to find the inverse however you want to. So you can certainly do a row reduction if you want to find the inverse that way. or you can use your calculator. So what I've done is I have put into my second matrix menu, I've edited matrix A to be this coefficient matrix. And just to show you, if you want to kind of pause and get caught up with me of what I have entered in matrix B, I have, in matrix B, I have edited that to be the coefficient matrix over here. So to keep them named something that is helpful for me to remember, I just put A in the A slot and I put B in the B slot. Now what I'm going to do is first I'm going to find the inverse of A, and for me personally, I'm going to save that in C. So I'm going to put myself a little note here that where I'm going to save this is in my matrix C in my calculator. So what I can do to do that is I can simply call up matrix A and I can use my inverse key right here. So your calculator will find it for you. Again, remember, on a find the inverse problem, that won't get you credit. But in the middle of a different kind of application problem, you're welcome to do that to save time. Now, I want to make this better readable, so I'm going to do a math and turn this into fractions. And I'm going to write that down. So my A inverse, which is saved, and I haven't saved it yet, but I'm going to. I should have saved it right then, but I forgot. So I'm going to do 1/20th, 0, and -1/4 as the top row, 0, -2/3, 1/3 as the middle row, and -1/40th, 5/6, and -1/24 as the bottom row. I'm going to go ahead right now and store that into second matrix. I'm going to store it in C. I'm just going to override whatever I have in there because I don't need it anymore. Okay, so I've stored that now. So now what I need to do in order to find X from here, X is A inverse times B. So I'm going to take this A inverse matrix, the one I have saved in C, I'm going to multiply it by the B matrix, which is the 420/50 column, and that is matrix B in my calculator. So I'm just going to solve the rest of this on my calculator. You could rewrite this matrix right here if you want to, but again, I'm going to save a little bit of time. So I'm going to now I'm going to go into my second matrix. I'm going to call up matrix C because that's where my A inverse is. And I'm going to say multiply that for me by second matrix, and I'm going to choose matrix B. So where I've saved those respectively. I'm going to hit enter. And it looks like the answers as fractions are 15/2, 10/3, and 55/12. It might be nice in this case to actually see those as decimals because it would be very strange. Remember, these are the answers for how many milligrams of foods A, B, and C. So if you go tell someone 15/2 grams, that doesn't make a lot of sense. So in this case, I actually might want to turn this back into decimals. So I'm going to do a math decimal. And this might make a little bit more sense to someone to say you need 7.5 grams of food A, or milligrams, and about 3 1/3-ish grams of food B, and about 4.5, 4.58 grams of food C.